I'll be demonstrating my technology review project in this video. I've chosen the gizmo whose name is Cat and the Mouse Chase, and here we're learning to model the linear equations in a real world situation. My learning objectives are going to be to model and interpret motion on a distance time graph, interpret the meaning of the coordinates at the point of intersection of two lines in a real world situation, interpret the meaning of the y-intercept and slope in a real world situation, and using a graph to solve a simple system of linear equations. This is my gizmo. So here we have the real world situation. The real world situation here is a mouse that's running away from a cat, and the cat wants to chase it and catch it. So we have some sliders here. We have a slider to adjust the initial position of the mouse. Oh. This slider adjusts the distance between the initial distance between the cat and the mouse. And then we have another slider that varies the speed of the mouse and another for the speed of the cat. So the red graph represents the speed of the cat, the motion of the cat, and the blue graph represents the motion of the cat. I mean the mouse, sorry. So in the form of exercise, I want the kids to explore this gizmo and see how these sliders affect the graph in terms of this situation. So if we have a slider, if I move this slider, I'm adjusting the initial position of the mouse, which is, this distance. And I want the student to see what happens to the graph as I do this. So as I increase the distance between the cat and the mouse, the graph goes up. The y-intercept changes. I really want the students to see that. And then if I change the speed of the mouse, the graph line gets steeper and steeper. The gradient increases. That's one point. And then as we adjust the speed of the cat, the gradient of the line changes. So you see? Okay. We have a simulation button here. So as we adjust the speeds and the distance, we simulate and see if the cat is able to catch the mouse, and it did. So I want the kids to see that whenever the point where the cat catches the mouse, that's the point of the intersection here. See, 15 and 15. So the cat catches the mouse at the 15th feet, 15th foot. So see, this is where the point of intersection is. I want the kids to really connect this situation to the graph and see how this happens, how this relates to graphs in a real world scenario. I also want the kids to find out in what certain situation and factors is the cat able to catch the mouse. Does that happen when the cat's speed is greater than the mouse's speed? Let's see. Or does it really depend on the initial distance? So these are all the factors that I want the kids to explore. And I also have an activity here for the kids. So as the students work through this, they'll have a better idea of how the real world scenario shows up on a distance time graph. So yeah, thanks.